Hello and welcome to A level chemistry online. This is the second video of Unit 1. Atoms and bonding. And this video is specifically about different kinds of atoms. In this video, I will talk briefly about atoms. We will look at atomic number and atomic mass. We will see that there are many kinds of atoms. And we'll introduce elements and the periodic table. Atoms are very, very small. Typically, an atomic radius is 3 to 0.3 angstroms. Right. That is 3 to 0.3 times 10 to the minus 10 meters. Now, what does that mean? If I take 1 meter and divide it by 10, I will have 0.1 meters or 10 centimeters. So 1 divided by 10 equals 0.1. We can write this in what we call scientific notation. That would be 1 times 10 to the minus 1 meters. If I repeat this process and divide it by 10 again, then I would have 0.01 meters times 10 to the minus 2 meters. So if what I'm doing, each time I move the decimal point, so if I move the decimal point to there, then I'm writing 1 times 10 to the minus 1. If I move it to here, it's 1 times 10 to the minus 2. If I move it to here, it will be 1 times 10 to the minus 4. 5, 6, 7, 8, 9, 10. So overall, this is 1 times 10 to the minus 10 meters. And it's scientific notation like this is a very, very convenient way of handling really, really small numbers. So 1 angstrom is this many meters. Angstrom. So let's try and put this number into perspective a little bit. If I was to take a large atom, the diameter would be 6 angstroms. And if I was to take a load of these atoms, as many as I could get, and line them all up in a row so that they were just touching each other, and that covered 1 millimeter, I would have 1 divided by 6 times 10 to the minus 10. And then I'd have to divide that number by 1,000 to get millimeters, because that would give me the number of atoms in a meter. A millimeter is 1,000th of a meter. So I divide whatever number I get from this by 1,000, and that would give me, in a millimeter, 1.7 million atoms lined up together. So that's a lot of atoms over a very, very small. So this gives you an idea of how small atoms actually are. And that's a big atom as well, like 6 angstroms across. There are currently 111 known elements or kinds of atoms. A pure element is a substance consisting of atoms which all have the same number of protons. We call the number of protons the atomic number, and we give it the symbol Z. Atomic number, we give it the symbol Z. Different elements have different numbers of protons. They are listed in the periodic table and ranked in order of increasing atomic number. So this is number 1. This is number 2. So these are the atomic numbers: number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we read from left to right and from top to bottom, and atomic number increases going this way and this way. We'll also see the periodic table is not a simple list, but it's organized into these kinds of blocks. So this here, this block here, is called the S block. This block here is called the P block. Between the S and the P block is the D block, and this one down here is called the F block. You'll see more clearly why this is electronic configuration of atoms, like how the electrons are distributed. For any element in the periodic table, let us look at an example. Tungsten, number 74. For this element, Z equals 74. So that means there are 74 protons. It has a symbol W, which is from the Swedish name for the metal of wolfram. We'll also notice that there's another number here, 183.8. This is the relative atomic mass, and we give relative atomic mass the symbol A. On some periodic tables, Z is at the top, A is at the bottom. However, except in the case of hydrogen, Z is always smaller than A, so it's always a smaller number. 74 is smaller than 183. And this is how, like, the easiest way to just tell. Always the case that Z is a smaller number than A. The relative atomic mass might look a bit odd since it's not a whole number, i.e. it's not 183 or 184. This is due to the existence of isotopes. Isotopes of an element are atoms with the same number of protons as a different number of neutrons. A typical sample of an element will contain mixed isotopes in particular proportions. The relative atomic mass, A, is given is the average mass for the mixed isotopes. For a single isotope of an element, often called monoisotopic, you can calculate the number of neutrons by subtracting the number of protons from the atomic mass number. So the monoisotopic mass number minus Z equals the number of neutrons. Some isotopes of elements are unstable. So for the first 20 or so, the protons and neutrons remain about equal. However, if I was to plot on a kind of a scatter graph, Right, so this is the number of protons, Z. We'll say that this is 20 here. And this is the number of neutrons. And this is a line where the number of neutrons equals the number of protons. Now, if I put a dot on this line for every single isotope that's ever been described by science, the isotopes that have been described, what we can see is that as we get heavier, we start to deviate away from this line of n equals z, where the number of protons and the number of neutrons remains equal, and it kind of goes up. So the heavier elements have more neutrons in them. And deviation away from this line makes unstable elements. And these are stable elements. And the unstable elements, some of them are so unstable that they've never been observed ever. So there's no dots down here and here. And there's a few dots sort of around this line here, as there's a few isotopes of the different elements, especially as we get heavier. So this is kind of accounts for the existence of isotopes and what exists. So the further we deviate away from this line here, the less likely it is to exist, basically. This is the line, which is the line of what is stable. In a neutral atom, the number of protons equals the number of electrons. So if we remember, protons have a charge +1. Electrons -1. So when protons equal electrons, sum of the +1s and the -1s equals 0. Now, electrons can be quite easily removed or added to atoms, and they generate something called ions. An ion is an electrically charged atom. Ions are generated by atoms losing or gaining electrons. If I take a chlorine atom, for example, so Cl, the atomic number is 17. In an uncharged chlorine atom, there are 17 protons, so that's 17 times +1, which equals +17, and there are 17 electrons, 17 times -1, which equals -17. So -17 plus +17 equals, so the sum of those equals 0. There are two common isotopes of chlorine. Chlorine 35 and Cl 37. So they are the masses of the isotopes. In Cl 35, I can work out the number of neutrons by subtracting 35 minus the atomic number 17 equals 18 neutrons. Similarly, 37 minus 17 equals 20 neutrons. So there are 17 electrons in both of the isotopes atoms. If I was to gain an electron, I would have 18 electrons. So in this situation, I would have 17 times plus 1 and to sum that up, I have 18 times minus 1. And the overall charge of the ion would be minus 1. And we call this a chloride ion, or Cl minus. Similarly, for sodium, symbol is Na, the atomic number is 11, mass number 23. So I would have 11 electrons, 11 protons, and for the 23 that would be 12 neutrons. Now sodium loses an electron quite easily, so 11 minus 1 E minus would be 10. So for the sodium ion, which is Na plus, there are 10 electrons, 11 protons, and 12 neutrons. This is a sodium ion. Sodium. So let's sum these up. 10 minus 1 plus 11 plus 1 equals plus 1. Given what we've learned today, for any ion, isotope or atom, we should be able to calculate the number of electrons, protons and neutrons simply by knowing the charge, having a periodic table to hand for reference. In view of this, it would be a good time to complete exercise 1.2. So all that's left now is to have a quick recap. So we looked briefly at size of atoms. We've looked at atomic mass and number. We've learned that there are many kinds of atoms. And we've had a brief introduction to the periodic table. So that's the end of this video. Thank you for listening.